Hi there, folks. My name is Kevin, and I want to welcome you all to the latest Best of the Best webinar series brought to you by the team at Novedge, the graphics and design software superstore. For today's webinar, episode 56, we are very excited to have with us Gabriel Mathews of PolyPlane. An industrial designer by trade from Portland, Oregon, Gabriel created PolyPlane to offer free weekly videos that help to explain the why more than the how-to of 3D modeling. The idea was to create a place where beginners could focus on the core ideas to help a person learn to 3D model fast. Every week, PolyPlane posts a new video with more advanced projects and other design resources for the beginners. For today's webinar, Gabriel shows you the basics from sketch to model, how to take an idea and then create it in 3D. Webinar attendees will learn how a simple sketch of a lamp can be easily transformed into a model that can then be sent to engineers for manufacturing. Different iterations will be shown through the Rhino 4.0 history option. The presentation itself will be about 40 minutes long, and in just a bit I will hand over the podium to Gabe. If you have any questions at any time during the presentation, please post them into the chat window so we can answer them during the Q&A session. Additionally, today's webinar will be recorded live, so if you want to rewatch episode 56 in its entirety, as always, you can find it on our Novedge Webinar series channel through Vimeo and YouTube. With that said, I will now turn it over to Gabriel. Gabriel, are you there?
Yeah, I'm here.
All right, I will change the presenter to you right about now.
All right. Can you see the sketches on my screen?
Yes, sir.
All right, cool. Hey guys, thanks everybody for coming along. If you came from my PolyPlane Twitter account, I appreciate it. So what we're going to be doing here today is going over rather quickly, because this is kind of a something that usually takes a little bit of a longer process to do. But we're going to take one of these sketches of a lamp that I came up with and take it from just a simple sketch all the way through to a 3D model that we could then pass over to engineers for like first round prototyping and that sort of thing. So I spent maybe like a half an hour, if that, just coming up with some thumbnails here of different, different lamp designs, kind of fun ones, funky ones, and whatnot. And from there, I wound up choosing this guy right here because it had a nice visual composition or whatnot. So then from there, I wound up making an underlay. So what I did was I took this this sketch here and copied it into a new document, and brought some lines over the top of it just to clean it up. And then from there, I was able to extract, a top view and a front view. Now, these aren't exactly perfect. As far as the front view and top view, because it was just a quick exercise in doing this. But if you wanted to, you could go back and really refine how these front and top views work. You'll also notice that the top view doesn't have the lampshade part of it, and that's because I really wanted to focus on the top view of just the base in that viewpoint to kind of give me a sort of a roadmap of what I was going to be building. Now, I'm not going to go completely into underlay preparation and all of that. If you're really interested in that, you can come over to the store, polyplane.com/store, and check out Sketch to Model. And this really gets into the nitty-gritty of concept sketches, refinement, and the preparation of such. But otherwise, we're just going to keep moving along here because we don't have a lot of time. So what we're going to be doing today is essentially making this lampshade, and we're going to be doing it in such a way that we're going to switch out the bulb using block instance, the block manager to do that. And then I'm also going to show you a little bit of the history command and what you can do with it based on the lampshade shape itself, using the curves as sort of a determining factor in how that thing moves around. So let's jump into a new document here. And here I have the underlays already set up. Actually, let me show you real quick how to bring underlays in, because I think you might find that useful. So we'll start a new document real quick. Yeah. And come into inches here. And there's a great command within Rhino called picture frame. And I'm just going to type everything out just because it's a little bit quicker for me. And we're going to use the lamp ortho JPEG here, and I'm just going to specify 0 as my starting point. You can drag out an image. Now if I look at this from the perspective window, you can see it's just surface with our drawing on it. Now this is a great first step in getting this thing into the place where we want it to be. So the cool thing about it, because it is a surface, I can now kind of isolate where my boundaries are of each component of the lamp. And I'm going to split the surface with those curves that I just drew, and then just get rid of the stuff I don't need. And I can come into my top view and rotate this along like so, and move that back into space. I made a copy of it. We'll just use the front and right view for this. And you can see how those kind of line up. Now I can select everything, go into my material here, and turn the transparency way up. And now it's kind of easier on the eyes, and you can kind of see what you're doing. And the idea here is to get the topmost point kind of aligned with the topmost point in your right view and your front view, so everything kind of lines up and you can get a good sense of how your curves are going to work. So let's get into the one where I have the lamp already kind of laid out as far as the underlays go, and start chugging along here. The first thing I want to do is actually focus on the lampshade, because it is the most complex as far as its organic nature, and I'm going to do this using the curve command, or the arc command, excuse me. And I'm also going to make sure that I'm on the curves layer, and this is just more of an organizational thing more than anything. So we'll draw out a curve here. And the cool thing about curves in Rhino, as well as most any other program, is you can rebuild them to have more control points. So with this one, it has 3 points right now that I can edit. I'm going to bring that up to 5, and then turn on my points here. Whoops. We also want to block the underlays, and just move these points around until you get them to a point where they're pretty close to what you designed. And then I'm going to draw out another one here and do the same thing, rebuild it, turn on its edit points, and then finally this 4th curve back here. Now because of the nature of these curves, there's something that's really important to point out when you're doing like super organic shapes and stuff. You have to really keep in mind how your tangencies are all flowing. So right now, this back curve that I drew, it's actually going beyond the constraints of this top curve here, and that's going to create a little pucker when I make this into a surface. So what I want to do is actually rebuild this curve to have more points, and then just move this back so that it stays beyond that extent line. And what that'll do is give you a much nicer surface continuity. So now it's in the side view, it looks all pretty, but let's look at it in the front view, and you can see it's dead flat. So what we're going to have to do is actually use the front view as sort of a defining curve of how that back curve flows. So what I'll do is, because I know the topmost point of the front view curve actually is down here, but our side view is more true to what we drew, I'm just going to draw from that top point here. Oh, and you want to make sure project is turned on as well. Now a lot of my PolyPlane viewers are probably wondering, gosh, he's really jumpy. Now all my videos are pre-recorded and edited, so all those oops and ums and ahs get out of the way. So let's just keep going here. I'm gonna move this curve. There's a lot of, you'll notice I keep going back and forth between turning project on and off. Now project just means that when it's on, it's projecting all of the curves and things that you're drawing to the active C-plane, the construction plane, which is this grid in the front view, grid in the right view, or grid in the top view. So it really depends on what you're trying to do at that moment. So what we're trying to do now is get this curve, because this is the top arc here, we're trying to get it to look like that in the side view. Now, if you've seen the flow videos on PolyPlane, you'll know that that's exactly what I'm going to do here. And again, turn project back on. Want to just define a backbone for this curve here, which is this right here. So let's just make it a little bit easier. I'm going to hide everything except for those curves so you can really see what's going on here. So we've got the curve that we want to target, the curve that we drew in the front view, and then the base curve here. So I'm going to type flow. I want to flow this with this base curve to this target curve. And hit enter. Oops. Let's do that again. Base curve. And make sure stretch is turned to yes. Now you can see that curve is now matching up perfectly. So looking at it, we're almost halfway done with the lampshade, which is great. So we can get rid of this curve now because we don't need it. But we still need to make the top view curve. Now I didn't draw the lamp top view curve, so we're just gonna arbitrarily pull out a curve here and rebuild it to something that looks good. And that, you know, that's sort of an aesthetic preference thing. So from what we're looking at in the top here, that looks about right. I'll move that with project turned off. And then again, we need to do the same flow command to make that happen. So I'm just gonna bring out a backbone here, and the same thing we did with the other curve. We want to flow this curve. This is our target, or that's our base, and this is our target. One more time. Okay. So you can see this backbone curve wasn't matched all the way, and that's okay. We're gonna just keep on moving here. And the way we'll get around that is by actually turning on the edit points for this curve and just move it into position with project turned off. Okay, so we have 3 curves. 1, 2, 3. We're going to mirror these. Get those into position. Now, I like these, but I think we need to match the curves to make it a little bit smoother. And we'll average those, and we're also going to join those. And what that does is it just makes the continuity of the curve a little bit smoother, so we don't have any puckers. And we're going to do the same thing with these 2 curves here. All right. So now we have 1, 2, 3 curves. Now I'm going to do this in 2 different ways. The first way is going to be the network surface command, and this is to really just show you how the history function works. And then the second, we're going to do the patch, and the patch surface it yields a better result for this kind of surface, but it really just depends on the application, because there are so many ways to generate surfaces in Rhino, so just keep that in mind. We're also going to split this because when you're generating surfaces, it's often and really important to work with something that's a little more quad friendly. So we've got 1, 2, 3, 4, and I'm going to turn record history on here, and I'm going to select all my curves, type network surface, and use the defaults. That's going to give me this cool surface. Now you can see why I used quads here. It really reduced the amount of triangles that appear. You only really have 2 triangles here, one here and one on the other side. So now if I turn on the points for those curves that I had and pull out, because the surface command was on, or the record history command was on, I can actually start pulling these points from the original input curves, and it's updating how that looks. Now if I were to offset this surface solid, you're gonna see it told me that I broke the history of the curves, so now if I update those curves, they're not going to update the surface because the surface is now broken. But the other reason I'm not using this is you can see there's a little bit of a pucker here from this sort of surface generation, and we don't really want that. So I'm going to go back to where my curves were just what they were and use the patch tool. And this gives me a much cleaner result. Now I can offset this like before, and check that out. You get a nice watertight solid shape. And I'm also going to fillet the edges because who doesn't like fillets? We'll make that 0.060. Actually, let's do that one more time. And yeah, check that out. It's pretty good. Now I could come back in here and analyze the surface just to make sure it's nice and pretty. I'm using the zebra tool to do that. And you're going to see there's a little bit of a break in continuity as far as how everything flows, but this is, you know, if you really want to get into that, there's plenty of videos on surface continuity that you can learn about that sort of thing, but for us, this will do perfect. All right, so now that that is generated, I'm going to take it and put it on a lamp layer and just turn it off because we still got a little bit of curves to draw here. We need to draw the holes. So I will use my circle tool, and we really want to make sure project is on for this because we're actually going to project these curves onto the surface that we just generated. Actually, we'll probably do a Boolean. That'll be a little bit easier way to do it. That looks good. The other thing I want to do is just kind of draw out where I think these arm pieces would go. Thankfully, because my center snap is on, I can quickly just snap those into place. Now you'll notice in the front view underlay, I've shown these arms going outside of the lamp and then back in. Based on the shape of the lamp, that's not going to work too well. So what I'm actually going to do is make everything come on the inside, and you can see that a little bit better in the final version. I'll open that back up so you can check that out. See how I've got them kind of all coming on the inside, and that's just because if I wanted to really go on the outside, it'd be a much more complex piping system that you'd have to generate to do that. So I'm just gonna bring everything on the inside. So I've got those, and I also have pre-drawn my base curves here, so I'm going to extrude that because it's not that bad of a thing to do. let's see, we'll extrude that. And from the top view, I can use these to kind of align where I want these to be. Project is turned on. All right, so that, and this one, I envisioned that one spanning the whole thing, so. And you'll notice that I keep going back and forth between extruding with both sides turned on and both sides turned off. It's just a matter of the fact that I built this thing on the 0 axis, so it's like on the y-axis perfectly. If I have something on one side, I'm only going to have to model this once, so I can now mirror this along 0 and get it perfectly into place, and I know it'll line up perfect. So these solids here, we're going to put those on the lamp layer, turn off our curves for a second, and we're going to turn off our underlay. And now kind of see compositionally and like visual weight how this thing is all working together, and I like it, so we'll keep going here. The other thing is, actually let me turn the underlay back on for a second. We've got a taper down here at the bottom. Rhino's got a great taper tool. So I'm going to taper this, middle's turned on. We'll taper it from there to there. And I'm going to turn infinite on. And now what this did was, you can see in the perspective window, it's actually tapering that how I need it to be. So the whole idea here is to kind of think about how your shape is going to work before you start editing it. So it's like, okay, I built my curve and then I extruded it out, then I tapered it. Now I'm going to join all these parts together by Booleaning them together so they're one solid shape. And then I'm going to start worrying about my fillets. So the cool thing about the way I've got this underlay trimmed right now is I can actually pull off a dimension to kind of get an idea of what we want the radius of that arc to be. So I'm going to fillet the corners here to be a radius of 1.32. And we'll do that in all 4 corners. And that kind of broke, so we might have to mess with that a little bit. So I'll take it to just a 1 because I'm pretty sure last time I did this, that's what we had happen. Yep. Okay. So now I'm going to invert everything and hide it, and then put some fillets back into this. So fillet edge and 0.12 I believe worked. And this is the other really cool thing about the fillet command is you get a really a nice result, as you can see, except for the face had gone off here. Let's see what the issue is. Sometimes if your fillet's too big, you'll get a lot of crossing faces, such as right there. So what I might do is actually, oh, you know what? We forgot one quick little thing here, and that is we need to extrude out this little guy too. And then Boolean that out. So we'll take that. All right, that's a little closer to what I had. And the other thing is we've got too close of a gap here for the fillets to work. So what I'm going to do is actually I think what I'll do is explode this, get rid of that surface, take all these surfaces, not those, join them, and then scale 1D from the top view, and this will give me just a little bit more space to work with in that spot. So that looks good. Take everything, join it, and then I will duplicate the edge of where that hole was. This is kind of the fun thing about working in Rhino is there's a lot of capabilities for you to, you know, make an error and then quickly resolve it. Now the dupe edge wasn't working for me, so I'm just going to duplicate planar surface, and I'll just grab all these edges here.
I'm wondering, Gabriel, could you remind us what you're doing here right now with the
Yeah, right now what I'm trying to do is, sometimes when there's a little bit of a surface discontinuity, you get some issues with how the fillets all come together. So what I was trying to do was actually repair the surface so that it wouldn't give me those little tweaks in the geometry. So what I might wind up doing is just going with a smaller radius and seeing if that brings it all together. And it looks like we're still getting some issues. So what I'm going to do, just to keep this moving along, is I'm going to take my old one, because it works, and just bring it in here. Okay, so now that we've got that, let's keep going. So the next part I want to do here is just finalize one last main form, and that's these pipes that we've got going on here, and that's these guys right here. Oops, got some Photoshop coming up. So from the top view, I'm going to turn on my control points, or my edit points, excuse me. There's control points and edit points. Edit points actually lay on the lines of the curves themselves. So move that one into position, and we'll move this one into position here. And then I'm going to add on a couple little branches so that this thing connects in. And we want to go beyond the surface. And what I'm doing here is just kind of creating the arms, and then we can take this and join it. And then fillet them. Those joined up, yep. So fillet. One side, and you can see I'm rapidly switching between viewports here when I'm working. If you're ever in a position where your viewports are fully maximized like this, you can actually tab through them. I'm just hitting Control Tab on a PC keyboard, and then I'm just going to pipe this, and we'll do that 0.12. There wasn't a join there. Oh, join those and then pipe them. So it looks good. And we do want these to go beyond the lamp, and this is because when we trim them back, we want to be able to trim them back in an accurate and precise way. So by going beyond, we can actually use the lamp as a trimming point. So I will quickly go ahead really quick and draw out the other arm and edit this curve here. So this one.
Hey Gabe, I was wondering if you could let us know
There.
what kind of commands you are using as you're going through the process.
Sure. So right now, everything I'm doing is pretty much just the mouse and the keyboard at this point. So what I mean by that is I'm literally, because my my curve command here was active. Once it ends, if I hit enter at the end of a command and I hit enter again, it reactivates the same command, so I can, you know, draw something out. And this just really speeds things up, so you're not clicking on icons, and you can really focus on the work. So I'm going to join these together and then fillet them. And it's the other cool thing about when you're working in Rhino is that it remembers your preferences. So these radiuses that I just made on this curve, they're going to match the one that I made before because it was the last input into that command. And you can see here up at the top where it says radius 0.12. And that's really useful because you're not having to constantly re-input new numbers. So I will pipe this, and again, same thing, it's going beyond the lamp. So we're starting to get somewhere here. I'm going to hide the underlay just to kind of see where we're at. Yeah, that's looking pretty good. I think this is a good time also to pipe this one here, and that is a closed pipe, so you don't always have to have open curves. You can actually pipe something that's a closed curve and get a good result. Not to give Autodesk too much of a plug here, but the pipe command in the new version of T-splines is unbelievable too. It gives you some really cool blends and fillets, so check that out if you want. So got one more thing to do to this lampshade, and that's to extrude it. Extrude the curves that are here, and these are going to act as Boolean operations on the lamp here. So we'll take the lamp itself, do a Boolean difference, and then we can delete those, and you can see now those are passing perfectly through the center. The other thing I might want to do here is give these a little bit of a fillet. Do that. Now I've got a nice soft rollover there, just to make things look a little more convincing. So those are passing through. At this point, we can also mirror over the those arms. And this is also a really good time if you ever receive a file from your engineering department. You can actually place it into the file using block instances. So let me demonstrate that real quick. We're going to select a file here. Let's see, we got we want the chord, so we're going to click OK, and I'm just going to place this chord here, and yeah, it looks good. Move it up. And there's a lot of hotkeys within Rhino that make things move pretty quickly. So I'm using I just use the M. If you just type M and hit enter, it'll automatically assume you meant move. And that's the power cord there. And then we're also going to insert a light bulb. So with this one, we'll do a CFL bulb. And we'll move it into position here from the top. And what I'll do is actually, it's got to generate the meshes when it imports a new model, so we'll rotate that around. Now, you know, I said that this was going to an engineering department. Realistically, you'd have a little bit more detail in this. as far as, you know, mounting points and stuff like that, but we're really trying to demo the software more than anything here. So to give you an idea, now we've got a CFL bulb in there, but say you get a change order and now it's an incandescent bulb. Well, the cool thing about this is I can open up the block manager and select the file that I want to update, go to its properties, and now we're going to make it incandescent. Click OK and update, apply all, and it'll think for a minute while it's locating it, and it did, so it told me it updated it successfully. So now you can see there's now an incandescent bulb in there. The cool thing about this is whatever layers are associated with the file will show up. So now the bulb is on the bulb layer, and I didn't even have to create a bulb layer. So it's really nice that it has some time-saving capability there. The other thing I'm noticing here is having a little bit of an issue with where the curve that created this pipe didn't actually pipe all the way, and that's probably because these didn't join. So I will go ahead and remove that and just make sure it's all joined up. And while I've got it here, I think I'll actually move it in slightly by turning on its points and just shift it over. Now I'm just hitting Alt right arrow, and that's nudging it into position. The cool thing about this too is if you're using a certain kind of curve, like a curve that has a continuity of 2, for instance, I think this one has a continuity of 3, it'll actually maintain any shape in the other viewport. So see how it's kind of still a straight line there. Here, because there was another edit point, it starts to get a little bendy. But frankly, I think that kind of looks interesting, so I'm going to keep it. So I'll select the whole thing, type pipe, and now our pipe updated, and it's got a little bit of an issue here. Now this is one of the other problems with when you're getting into control points and messing around with them, is that sometimes you'll lose your continuity within the pipe. So we're going to have to undo that to get it where we need it to be. So what I'll do is actually select those points as well, and what that'll do is actually just keep everything together. So now when I join this and then pipe it, it's nice and clean. So you really want to affect all of the edit points that represent the curve that you're trying to edit, or at least as many as you possibly can. That'll greatly reduce any issues you might have. Now the other thing in the original model of what I drew, I actually had like a little rubber handhold here. Now the way I did that was, I'm going to hide this part, and I'm actually going to explode this curve so it's just this piece, and I'm going to pipe just that. And we'll do that at 0.25 as the radius. That's a little big. Maybe we can do 0.1875. That's a little more realistic. Fill at the edges of it at 0.06. That looks pretty cool, but we could actually add a little bit of a grippy finger bump sort of thing to it by using just a primitive of a torus. And the larger the radius, the wider those handholds are going to be. So I'm kind of digging that. It might be a little bit too big, actually. Let's scale it down a little bit. Maybe like that, and then just shift it over. And now what I can do is take the original curve that I use to pipe and type divide, and we'll do this at 5. And what that did, you can see in the top view here pretty easily, is it actually gave me some points that I can use as a reference point for when I array this. So I'll move this from here. Oh, we've got center snap on. Center snap can be a little pesky when you're working, but move that and then array it 4 times, and then use the divide points as your spacing. And then we'll take the handle here and just boolean those toruses out. That gives you a nice little hand dent sort of thing. So let's make sure everything is still on the lamp layer. This, and this. Put those on lamp layer. I love lamp. All right. And that gives you your basic form. Now, if you wanted to detail this, one thing you can do is actually add some plugs in here. If you remember from the final version here, I have these, like, let me hide the lampshade for a second. I've got these plugs that are in here. Now, what I did for that was I actually took my original curve and exploded it, so just the radius was what I was grabbing, and did a pipe with a larger diameter. And to get the actual piece here, the larger ellipse shape, what I did was I duplicated the edge using, or I'm sorry, I used a patch command. And selected the curve that made the outer ring. So I'll hit enter and preview it, and it'll give me like this nice kind of satellite dishy sort of parabola shape. Click OK, and then offset that. Oh, you know what? That's going to give me too tight a ring. Let's use one of the outer ones. Use that. And then let's see, that's also giving me kind of a funk. Maybe dupe the edge. And the radius might also be affecting this, I'm not sure. Let's preview that. All right, we'll use it. If that's going to give me some ugliness, yeah. So depending on the radius, so with this lampshade, I used a 0.03 radius on those fillets. If I had used a larger radius, that would mean that this edge would actually be closer to the center between those two distances, and that would give you a cleaner edge. So what I'll do is I'll just show you the curve that I used to generate this one. For instance, I used this one right here, duplicate the edge. I believe it was that one. I drew a patch through it, and it gives you a nice flat surface to work with. Then you can run the offset surface, flip it, make it solid, and then do it at like 0.03. Or 0.03, not 0.3. And you can see that gives you a nice little solid to do some Boolean operations on. And you can go along and then run the pipe command on the other part of the curve here. So this curve stops there, but it's also the original curve that was used to make this. So if I deselect that and give it a larger radius, you can actually create a larger pipe, use that patch as sort of a splitting point, and then join those two together and give them a fillet, and that'll give you the nice smooth shape that you have. Now, just to jump ahead a little bit here, assuming you had done all that, what you would next do is select all your curves by using SEL CRV. Just make sure those are all on the curve layer. Make your lamp the active layer and turn off the curves. Let me turn curves on for a second here. You also want to make sure that your block instances are staying on their respective layers. The bulb is also on the wrong layer, so we'll put that back on bulb. Click OK. And the reason that happened is whatever your active layer is, see that little check mark there. If that is active, that means even though you're inserting something that has the name chord as a layer, it's still going to import itself into whatever your active layer is. So you got to keep that in mind. So we're going to call this and assume it's done at this point, just to keep things moving, and select everything and hit Alt FA. And what that'll do is actually give you the option to save this out as a different file. Now, Rhino has a whole bunch of different saving options. The people who use SolidWorks, we've got IGES and step file in here. And what you can do is just select that, make sure its suffix name is matching correctly, and click Save. And then you can, use any sort of, one of your popular step file export options and click OK, and it'll actually export that as a step file. So with that, if there's any more details that you wanted to put in, you totally could. You could, take this base section here and start to work on shelling it out and thickening it so it's actually has some volume. Maybe we'll take this and just type project and remove the curve, split that with that curve, and now you could shell this. I would probably sooner do this on the SolidWorks side to thicken it, but you can start to figure out how your components would fit in there, or obviously a big design flaw with this is how does the lamp stay on top of the lamp shade, because gravity still works. So we probably put some mounting brackets in there and run a cable through one of these arms and then down into the base and then out to the power. So it really does offer you a nice balance between sketching out an idea and then going back and editing it, keeping in mind that sometimes, as you saw with the base, that the fillets can be a little bit daunting at times, but it's just a matter of A, the size of the fillet that you're using, and B, just kind of how your mesh is drawn out. If you ever get into a position where your mesh is looking a little strange, one quick fix for that I've often found is to go into your preferences by just right-clicking the render globe, or you can come up to, I believe it's edit preferences, no, file properties, yeah, and just go click on mesh, and I've got it on smooth and slower. If I do it on jagged faster, it'll give me a less refined mesh, but it'll display a lot quicker. Or you can make a custom mesh, and it'll think for a minute before it rebuilds it. So that gives you a little bit more display opportunity there. So while that's thinking, I think we can open up the floor for any questions that we might have. Kevin, did you have any questions for me?
Yeah, we actually have a bunch of questions. Let me start off. Some of them I answered already, but let's start off with Lance. Lance wants to know how you load the underlay.
Oh yeah, yeah, sure. Lance, you may have joined a little bit on the late side. I don't know, but I can show you real quick. We'll use the bulb as a sort of a blank slate. So what you do is you can do it a couple of ways. My favorite way is to use the picture frame command. So you type picture frame, and then it'll look for a file, and then you can put a whole slew of different file types in there, and then just drag out your size. Now, one quick thing to note, you actually bring up a great question and a great point with this, is how do I know what scale this is? Now, you could use the grid units, but one thing that I always do is I just find a line that I know is going to be, so I know that the tube or the pipe that's going to run down these arms is going to be 0.125. So if I just draw out a line that represents the diameter of that and select my surface, I can then type scale and say 0.125, and that'll get everything perfectly to scale of how I need it to be, and then you can trim it all back. And then the other part of that, which I would assume would be a question, is how do you get the opacity to change? And that's to go to material with the picture frame selected, and just go to basic, and then click on click on transparency down here, and just type that to 80, and that'll give you a nice soft underlay to work with. So that should help you out. The other way you can do it, if you want your underlay to stay pretty static, is what I did was I just right clicked on my viewport name, go down to viewport properties, and you can put in a wallpaper option. So I clicked on browse, and then click open, and now what that'll do is that'll actually create an image that's on your background. And the only issue with that is it doesn't move with your camera. It's just like a static thing. Now the benefit of that is for compositing, or maybe you just kind of want to get the scale of one thing to another. I don't really use it that often, other than kind of comping things in a scene to see how they might look compositionally. Otherwise, I don't use it that often. So yeah.
All right. Do you want to try another question?
Yeah, sure.
Okay. Thank you, Lance, for that question earlier. Well, David wants to know if he wants us to be able to see how you repaired the surface continuity, because we all run into the fillet problems.
Oh, that's a good question. So, oftentimes what will happen is, let's get out of here and go back into our lamp. So what I did, part of this was this filleted poly surface here is actually broken, and it doesn't look like it, but if I were to zoom in really quick to this area here, you can see this is like the prototypical issue with fillets. I have a fillet that's coming in this way and a fillet that's coming in this way, and there's an overlap between the two, and that's just a radius issue. The radius of that fillet is too big for that space. So what Rhino did was it said, okay, I'm going to draw them both. When you're in the actual fillet command, so let me draw out a box here real quick. Here we go. When you're working with a box and you fillet it, we'll do 0.06. It looks great, okay? But I want you to look at the actual command line. I hit enter, and before I hit enter again, you can actually preview what that fillet is going to look like. And all I did was clicked on preview. Now there's all sorts of different sections in here that you can mess with. One often that I use is I'll add a handle and then edit that handle and make it bigger or smaller to see how that affects my fillet. If I click on preview again now, I'm going to see that fillet there is not in conflict with anything, so I might get it to that point and see if that messes it up. And sure enough, it was able to make that big fillet, but not before messing up these corners. So let's say that corner, it gave me a result where it wasn't able to generate what this surface was, and it was just a hole. And that's one of the common problems with the filleting tool, is that you'll get all these holes everywhere. Well, one way to do that, one way to solve that, is actually just select those edges with the patch command active, and then see what you can come up with. Another way is to actually just use the network surface command, and then select all those curves, click OK, and that gets me a little bit closer, but it's not great. So it's a lot of trial and error with the actual numbers. There's a blog out there, Industrial Design Sketching, which actually did a modeling demo to fix fillet edge continuity. I mean, it's a big subject. So it's just a matter of playing around with your fillets. I mean, I hate to dismiss the question and it's just like, you know, just figure it out. But oftentimes that's all it is it's about experimenting with what fillets work. Rhino is great for surfacing, not the best for filleting, in my opinion. I think SolidWorks does a little bit better because it'll kind of, you know, just not do a fillet if it won't work. But you know, otherwise I would say experimentation is definitely key. If you get an issue where oftentimes your result will look something like this, where your fillet will be way out here, and it's like, well, what the heck, what am I supposed to do with that? What you can do is actually come back down here and trim using adjoining surfaces. So I'll hit enter and then just trim that back, and then just join everything back together, and then do the same thing up at the top. But otherwise, yeah, it's a lot of experimentation.
All right, thank you, David, for that question. I hope that answers it. Once again, if you have any other questions, do check out the PolyPlane website, and I'm sure in the forums, Gabe can answer that more in detail. Okay, let's look at Denise.
Absolutely.
Denise wants to know, how can I add a control point to a curve?
Oh, great question. I probably went way too quick over that. There's a few ways you can do it. I'll just show you two. So you have a curve here. What the first thing you can do is you can actually rebuild the curve, and that'll add an even array. So we'll use 10. Right now this curve, you can tell by the point count, it has 3. Whatever that number is, that's what it has. And we'll make it 10. And we'll click OK. And then if I turn on my control points, you can see there's 10 points going along there. The other way to do it, and this is kind of a more controlled way, is to just insert and then edit point or control point. So I can select anywhere on here and it'll start to adjust itself. It'll maintain, see that one point is kind of scooting itself around. That's because it's trying to maintain the shape of the curve. But that'll definitely add in a whole bunch of points, and then you can, you know, move them around as you need to. One thing I would say, and this was a great topic that came in on a webinar I was listening to on T-splines, was actually make sure that you really need the control point or the edit point. A lot of times people think that by putting in a whole bunch of edit points or control points, it's going to help you define what you're trying to show. Oftentimes you only need like 3 or 4 control points on a curve to really be able to describe it, unless you're doing something that's highly organic and has like a whole bunch of like little kinks and puckers. The closer your points are together, the sharper your form is going to be, and the further away they are, the more of a broad, smoother shape you're going to get. So, and that command also works on surfaces. So if I were to, let's say I exploded this and I wanted to insert an edit point on here, or excuse me, insert a control point on there, I can now, you know, add additional points on here, and I can also change the U and V direction. So now it's going this way, and you can do that a lot. But I really recommend If you can avoid it, do it. But I mean, there are going to be times when you need to add points. So that's a great question, and I hope that those two help you. So there's insert or rebuild are the easiest ways to do it.
Okay, Denise, thank you for that question. All right, Lauren wants to know, where did you get that insert menu, or where did that insert menu come from?
Say that one more time.
Lauren wants to know where that insert menu came from.
Oh, sure. Yeah. One thing you can do, you can just type insert into the command line, and that'll give you your options here. The other way to do it is just to type rebuild, and that brings up your rebuild surface prompt. There should be also, if I can find it, I never use the menu bar up here. It's just one of those things some people use, some people don't. But there are ways down here, so like edge tools, rebuild edge, and curve should be the same. Rebuild curve should be around here somewhere. But yeah, it's usually in your menu, but I just type out insert.
All right, thank you, Lauren. Sid wants to know, wouldn't it move faster if you just linked instead of embed?
The question kind of trailed off there, but I think the question was, should you link instead?
Yeah, he wants to know would it not be more faster if you just linked instead of embedding?
Yeah, it absolutely can. The only issue with that is you have to, if you're going from computer to computer, if you link them, yes, it will be faster. However, you can't assume that everybody's on the same network. If they are, by all means, link the model. I always insert it because oftentimes I'm moving from one network to another, and I want to keep my block instances inside the model. And then that way, if I come back to my computer and reload the file, any of my original links will still be intact. But yes, to answer your question, yes, it is faster, but not a lot, because you still have to display those meshes. So your performance isn't altered horribly. It just makes your file a little bit bigger when you embed it.
All right, thank you, Sid. John wants to know, I noticed you joined first, then fillet. Is there an advantage over fillet first, then join?
I don't think there's much of a difference. So if I have a curve and it's got a kink like that, if I fillet it, what it's going to do is it has to rebuild that as 3 curves, so you still have to join it. If you were to build out a curve and then build out another curve and then put an arc between them, then you have to match them. And so, I mean, it's really a preference. I really do think you're only saving a matter of seconds, at that point.
Okay, thank you, John. And Denise has another question. I think this will be the last one for the Q&A.
Sure.
How can you make a volume extending to all directions at the same time when you have a surface network?
How can you make a volume extending in all directions when you have a surface network? I'm not quite sure I understand that question. I don't know. If you want to email me that question, it's pilot@polyplane.com. I'm happy to answer that in depth, because I would love to be able to answer as many questions as you guys have. Otherwise,
Okay, there you go, Denise. If you have any questions, please email Gabe at PolyPlane. All right. Gabe, is there anything else you want to go over? I think you were working on something, right?
Not that oh, you know what? The one thing that this is about, if you are a member on PolyPlane, which I recommend you do, let me get back to the home page for a second here. We're doing a monthly modeling challenge that's still intact. Now, if you're, all you have to do is, make some funky cool lamp and register yourself on the site, and then you can upload images, and it's community voted, and the winner is going to receive a 3D print of their model, thanks to Peak Solutions here in Portland, Oregon. Otherwise, that's all I got.
It's all good, Gabe. All right, I'm going to switch the presenter back to me right now. Good to go?
All right.
Cool.
Thanks so much, Kevin.
No worries. All right. I want to thank you guys so much. I want to thank you, Gabe, for joining us today and co-hosting this really, really cool and detailed webinar with us. On behalf of the team at Novedge, I want to thank you for joining us as well, our audience members. Now, for more tutorials and how-tos, I want to encourage you guys to check out Gabriel's website at www.polyplane.com. If you have any questions about his work, feel free to reach him there. In addition, you can, Gabe already mentioned this, but you can follow polyplane.com on his Twitter at polyplane. There's a bunch of stuff, and every week, as I mentioned earlier, there's a new weekly video that Gabe posts. In addition, if you want to learn more about Rhino 4.0 and all its capabilities, do head on over to the website at rhino3d.com. And if you notice on the left side, it's more than just design. There's a lot of things and nifty things that you could do with that. For pricing information on Rhino 4.0, visit our website at novedge.com. As the leading graphics and design online software superstore, we pretty much have the best prices around. You can call or chat with us anytime. And for any and all information about Rhino 4.0, you can speak with our specialist, Bob Dayer, at bob@novedge.com. Here at Novedge, we have created several communities to foster collaboration and communication between design professionals. At rhinojungle.com, you have access to all the latest industry news and videos. Furthermore, we encourage community members to share their experiences and tips through discussion and content. It is free, and the process to sign up is easy. And on top of that, a short weekly newsletter with the latest buzz are yours to enjoy. So head on over and check that out for sure. Now, if you have any questions, comments, or concerns about this webinar, about how we can improve it, please don't hesitate to email me at kevin@novedge.com. And here's a heads up. In our next upcoming webinar in 2 weeks, episode 57, Jonathan Pickup of ArchonCAD will talk about the latest features and changes in Vectorworks 2013. From imports to exports, site modeling, spaces, and plants, bottom line is that this is going to be a jam-packed and very information-heavy webinar where Jonathan Pickup will show you how your workflow with Vectorworks 2013 will be faster and more evolved. Registration is free, but space is limited, so for more information on how to sign up, visit our page at novedge.com/webinar/57. If you want to rewatch episode 56 and our other past webinars, this episode and others can be found on our Novedge Webinar Series channel through Vimeo and YouTube, so stay tuned. On behalf of our team at Novedge, I want to thank you guys for joining and watching us. Have a good one. Thanks.